This is a recording on how to do calculations for the spectrophotometric analysis of copper experiment. And to remind you, there are three unknown compounds for which you have solids, where you can calculate from their formulas the weight percent of those compounds. And you can do that there. And there's also a sample of copper ore for which you can't actually calculate a weight percent because it's not a pure substance. And so the goal is to determine the percent of copper in three unknowns and figure out which one of these three compounds they are, and also just determine the amount of copper in the copper ore. And so the first part of the experiment, students make up a set of four solutions that have known copper concentrations. We call those standards. And we've done that in a separate video. And so in the first sample, it's just nitric acid, so there's no copper in it. It has a zero concentration and a zero absorbance. And then there's three other samples. The fourth one is the copper standard that's provided, and that is given as 0.953 grams of copper per 100 milliliters of solution. And grams of copper per 100 milliliters of solution is the concentration unit we're using. And so the fourth solution is just that solution, so that's its concentration. And solutions 2 and 3 are made by diluting the copper standard by a certain amount of nitric acid. And those calculations are in a separate video where it shows how to make the standard plot. And so you make those four solutions, you get your four absorbencies, you put them in Excel, you get a standard plot, and from that plot you get a y equals mx plus b equation. And that's the equation that relates absorbance to how much copper is in the solutions. And in this particular made-up case, the slope is 0.9186. The intercept is minus 0.0333. The R-squared value is an indication of how well the points fit on the line, and closer to 1 is better, and 0.9891 is good for this kind of experiment. So it says the experiment was done pretty well. So then what the purpose of this video is how to take that data and also the data for the unknown compounds, and from that determine the percent copper in those compounds. And so first of all, we're going to show how we use this equation to relate from the standard plot to relate copper concentration to absorbance. What we do is we take the y equals mx plus b equation, and we realize that the y-axis are the absorbance values, and the x-axis are the copper concentration values. And so we rewrite the equation with absorbance and copper in it, and we reorganize the equation, rearrange it for the copper concentration. So the copper concentration is equal to the absorbance plus 0.0333 divided by the slope 0.9186. And that means that we can take any, once we have created this standard curve and are using the spectrometer in real time, the same time we've made those measurements of those standards, we can measure the concentration, we can measure the absorbance of any other solution. And effectively what we're doing is we're saying, if you measure the absorbance, it's a different color here, you can go over to the line and go down there and figure out what the copper concentration is. But we're doing that not just on graph, we're doing it numerically using the equation for the line. And so once we have this equation here, we can measure the absorbance of any solution and determine the copper concentration in units of grams of copper per 100 milliliters of solution, even though we don't have 100 milliliters of solution. So we're going to do a dumb unknown. This was done in the lab for three different compounds, A, B, and C, for which one was supposed to take a mass of around 0.18 grams and dissolved. Let me get my pen back here. Dissolved in exactly 10 milliliters of solution using a volumetric flask. And let's say, I'm just making this up, 0.158 grams for the mass, and let's say the absorbance was 0.436. We want to figure out what's the percent of copper in that compound that we have there. So what we're going to do is, the first thing is we're going to take absorbance, and we're going to convert that into the concentration of copper. We're going to use our equation for that. So the copper concentration of copper 2 plus in grams of copper per 100 milliliters of solution is equal to the absorbance, 0.436 plus 0.0333 divided by 0.9186. I'm going to do that on my calculator, and you're going to wait for me to do it or not. And I get 0.511 grams of copper, 2 plus, per 100 milliliters. Now, in our case, we made up the solution for in a volumetric flask that had only 10 milliliters. So what we need to do is, you can just do this in your head in one way, but we'll do it mathematically, that the solution has 0.511 grams of copper per 100 milliliters. We only had 10 milliliters, 1/10. So the amount of copper in our solution was really 1/10 this. But let's go ahead and do it out longhand. So we had 10 milliliters of solution times 0.511 grams of copper, 2 plus, per 100 milliliters of solution. And that means we had 0.0511 grams of copper 2 plus in our sample. Remember, this is the sample that had a mass of the sample that the solid we weighed out was 0.158 grams. So then the percent of copper is going to equal the grams of copper over the grams of compound. Compound is the same thing as the sample, times 100. So that's going to equal, the percent of copper is going to equal 0.0511 grams of copper divided by 0.158 grams of compound times 100. And that's going to give us, divide by 10, divide by 0.158, and that gives me 32.3%. Okay, and so the students will do this for each of their 3 compounds, A, B, and C, and could do it for 20 other compounds. Okay, next what we did is we also had the copper ore. We're going to determine the percentage of copper in the copper ore. And this is a little different because the copper ore solution was prepared by taking 49.8 grams of copper ore, that's from a rock that got crushed up and was dissolved in nitric acid and eventually diluted to a total volume of 500 milliliters. And we're just making up an example here that what if the absorbance of that solution was 0.436 absorbance units? We use the same equation, and so what we're going to do is we're going to figure out the copper concentration for that solution. So the copper concentration from the ore solution is going to equal 0.436 plus 0.0333 divided by 0.9186. I'll do that. 0.436. That's not the same number I used before, is it? Oh, it's the same number I used before. What a bum. I'm going to change this. Sorry, class. I'm going to change this to be 0.381. Let's say our absorbance was 0.381. Okay. 0.381 plus that equals that, divided by 0.9186. So I get 0.451 grams of copper 2 plus per 100 milliliters of solution. Now, in our case, we actually didn't have 10 milliliters in this case. In this case, our copper solution was 500 milliliters. The copper solution we made was 500 milliliters and has a concentration of 0.451 grams per 500 milliliters. So the amount of copper is going to be 500 milliliters of solution times 0.451 grams of copper, 2 plus, per 100 milliliters of solution. And so that's going to be that. That's going to be 2.26 grams of copper in the ore sample. And the percent copper then is going to equal the grams of copper over the grams of ore times 100. So it's going to be 2.26 grams of copper divided by 49.08 grams of ore times 100. So in this case, divided by 49.08, we come out with 4.59% copper in that ore. Okay, that's a made-up example. So those are the way to do the calculations for this experiment.